is addition, and then division is subtraction, trying to get as close to 0 as possible. We have a comment, by the way, that says, "Thank you for doing math that I can actually understand."
Yes.
You are very welcome, Carsey. I'm glad that we can help you understand.
Yes. It is very fun to have people understand this. Okay, so from our discussion of multiplication and then division, Kip was saying it leads us into inverses, like inverse operations. So, Kip, what do you mean by inverse operations?
So by inverse, I just simply mean the opposite, okay?
Okay.
So I think it's pretty intuitive for people that for everything you do, right, you can do the opposite of it for the most case. So in the case of addition, right, well, if I had 3 apples and Jaden had 5, and we put those together in one,
Ooh.
or 2 apples. Sorry, Jane only had 2. I'm getting being to, and we add those together. We'd have and we put them into a box, right? We'd have 5 apples. Well, what if me and Jaden decided that we wanted to take our apples back? So how would I figure out how many apples? I guess if Jaden took his 2 apples back, right? We would subtract 2 circles from this because Jaden wants his apples back, and now there's only
Yep.
3 left in the box, and so that's the opposite, right? That's an inverse. So
Right.
subtraction is the inverse of addition. It's being able to turn things back to, it's to do the opposite of whatever you did to get there, right? So it's the same as if you were to drive to your work. Well, then to get back from your work, you have to drive back from work to your home. And so it's
Right.
doing the opposite. So you're at a starting place, and to figure out how you got to that starting place, you do the opposite of getting there, if that makes sense.
Yes, that makes sense. Um, this is also like using inverse operations is very useful when you are like solving equations. And what I mean about equations, it's like 2 plus x equals 4, right? So you have to do inverse operations to be able to solve for x. Okay. So a positive 2, you would have to subtract 2. That's the inverse of a positive 2. Subtract 2, you get x equals 2. A lot of people would have been able to just say, hey, x equals 2. I already know 2 plus 2 equals 4. But that's just showing you where inverse operations are very useful in solving different equations.
Right. So, yeah, I mean, to put that in, it's very useful. And this is the thing that, I don't think people realize that they do on a daily basis, right?
Right.
These small little inverses, yes, when we get into more complex math that we sometimes do on this channel, you don't do it on a daily basis. But most people say they don't understand math, yet they do it every single day of their life, right? Like if they're like,
Yeah.
well, if it's 7:30 now, right, and I need to be somewhere at 8 o'clock, how much time do I
How
have
much
left?
time do I have to poop?
Right. Yeah, how much time do I have to poop? Right. And that's something I constantly do it, right? It's like, okay, I have
Yeah.
this many minutes to get this done. And that is what we're doing here, right? You're saying, well, at 7:30 plus some number equals 8 o'clock. And so you instinctively know that you're going to subtract 8 o'clock from 7:30 and you're left with 30 minutes. People just
Yeah.
know that automatically. And, I don't know as if they actually do know it automatically as much as it was taught to them in school, but I don't think that they realize that exists, right? That they are doing algebra on
Yeah.
a daily basis. And
They're
it is
solving
useful.
for the unknown, which was that 30 minutes that you have to brush your teeth, get dressed, do whatever, right?
Right.
And then get to your destination, what you were doing. And that's solving for this unknown variable. It's just intuitive to people. But once you write down an equation like I did, the 2x or 2 plus x equals 4, people kind of just shut down. And that's kind of what Kib and I are like, hey, you're doing it. You just need to calm yourself and you can do it.
Right. Because written out math really is just a language of trying to explain what we already do on a daily basis. So,
Right.
okay, enough ranting about how you use math. Um, but by the way, dude, that is definitely math magical. I think that you use math all the time,
Yes.
and it's all these things. Did we solve anything? You solved something. You solved for x, so that question
Heck
is solved.
yeah.
Okay. Um. So let's keep going here. Let's keep talking about inverses a little more, right?
Right.
If we, so Jaden, if subtraction is the inverse of multiplication, or sorry, if subtraction is the inverse of addition, what is the inverse of multiplication? We kind of already went
Uh,
over this, but
since I am just a great student, and since we only talked about addition, subtraction, multiplication, and division, I'm gonna go ahead and say division.
okay. So multiplication, dude, you're absolutely right, by the way. And if you were an even better student, you would have paid attention enough to know that I already said that. But
You just say, okay. Gold star, Jaden. Come on.
dude, I need a gold star button. That's what we need.
Pat me on the back. All right. Yeah, so multiplication and division are also inverses.
Okay. So if a
Okay.
way to think about this, right, is if we had the same thing, right? If we had these boxes of three circles again, and we had three of them, and we're like, yay, we've got three boxes of three. We know that from before is 3 times 3. Well, what
Yep.
if we had our boss again tell us we needed three boxes, or we needed boxes, we had 9 circles, and we needed 3 in each box, but we didn't know how many went in each box. So Jaden used an X. I'm going to use a question mark because I'm confused.
Yeah,
So,
why do we need the letters? That's just to have something fill in space. You could use a question mark, you could use a triangle, a smiley face, a star. Uh,
a Santa Claus because
they're
it's
all
Christmas time,
they're all the same to me, right?
or a menorah if you're, either or.
Oh yeah,
We don't.
Hanukkah starts tonight.
It does. Happy Hanukkah,
It does.
everyone.
Yeah, happy Hanukkah.
See, dude, I don't. I'm one of those classic people out there that's ignorant about other people. I guess I need to work on that. But, anyways, back to this question. So, if I was to divide by 3, right, by both sides, like that, you would
Uh,
get this question mark is equal to 9 divided by 3.
right.
So you do that inverse, right? So we know we're multiplying by 3. Um, and we
Oh, Kip.
what?
our bottom 3 here is cut off.
Uh-oh, you're right.
So this one is cut off. So
I'm gonna write it up higher. Whoops.
okay.
Thanks, Jaden, for noticing that. I appreciate it.
Yeah.
Okay, so if we have, what's happening? My pen is attacking me. Okay, so if we have 3 times question mark equals 9, if we divide this whole thing by 3 and divide that by 3, then we get our question mark equals 9
So
divided by 3. So we're doing the inverse, right? So we have this 3 times something equals 9, and so to figure out what that something is, we have to divide by that 3, the inverse, to find it, right? We're working backwards. We're going back in time, essentially. In a kind of way.
Something that most people can relate to is shoes and socks, right? In the morning, to get my shoes on, I put on my socks first, right? So socks, then shoes. But after work, I come home, I don't want my socks on anymore, so I have to take off my shoes first and then my socks, right? Most people do it that way. I'm sure there's some people out there that might do socks over shoes or something weird, but most people, okay, is shoes or socks then shoes. Then when you take them off, it's shoes and
putting
socks.
my socks over my shoes? Should I start a new trend?
I mean, if you want soggy socks, dude.
And sweaty feet? And
Yeah.
shoes?
Yeah. So just think socks and shoes, shoes and socks, right? You gotta take off your shoes before your socks, and you gotta put on your socks before your shoes. So that's the exact same thing as these inverse operations that we're talking about. If you first add something, then to undo that, you'd have to subtract it. And if you first multiply something, then to undo that, right, you would divide it.
Right. Like if you left your shoes on and tried to take off your socks, it wouldn't work. I mean, you could maybe rip them off,
Yeah.
but you definitely would not have the same sock you started with.
Yeah. And if you want to try it at home, go for it. You know?
I want to start a new TikTok trend, dude. People trying to take off their socks inside their shoes. Jaden, you're glitching out a bit, but you'll be okay. You'll make it.
I'll make it. Can you hear me right now?
Ooh, we got a question I hear you. That says, "What if you are Jared and don't wear shoes?"
Great question. If you are Jared and don't wear shoes,
you're probably not wearing socks either if you're not wearing shoes, is my first assumption.
Yeah, you're just not doing operations, you know?
Yeah, you didn't start with anything. Yeah, so you have to do the opposite to get back to where you started, right? So
we got another question. Why is 0 only maybe a natural number? So short answer for a big debate among mathematicians. It is very useful to have 0 as a natural number in certain circumstances, and it is very useful to not have it in other circumstances. So there are mathematicians that are like, hey, I really like 0 as a natural number, so they claim it as a natural number. And then there's the opposite. So that's why.
That's a good why. Yeah, I mean it boils down to the properties of a 0, right? Like so, in this case, let's talk about this one actually, because this is something that people do get confused about, and maybe we're going too far ahead, but since someone asked about zeros, why not? Let's create a new slide. This may be confusing.